Hello everyone. Welcome back to the course of Software Analysis and Design Patterns. This video is brought to you by Newton's Group of Institutions in association with Redefined Solutions. This is Aravind Yegireddy from the Department of Computer Science and Engineering. And in this video, we will discuss about design patterns. In our previous video, we have seen what is a design pattern and what are the four essential elements in the design pattern. Design patterns in Smalltalk MVC, and we have discussed about describing the design patterns. Now in this video, we will discuss about the catalog of design patterns, and we will discuss about organizing the catalog, and we will see how the design patterns solve the design problems. And we will also discuss about how to select a design pattern and how to use a design pattern. Now coming to the first topic, that is the catalog of design patterns. So the catalog contains 22 design patterns. Their names and intents are described in the video to give an overview. The first one is abstract factory. So which provides an interface for creating the families of related or dependent objects without specifying their concrete classes. And the second catalog is adapter, which convert the interface of a class into an other interface according to the client's expect. So here the adapter lets the class work together that could not otherwise because of the incompatible interfaces. And the third one is bridge, which decouples an abstraction from its implementation so that the two can vary independently. Fourth one, builder, which separates the construction of a complex objects from its representation so that the same construction process can create different representations. Fifth, chain of responsibility. So here, this avoids a coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. Here, chain the receiving objects and pass the requests along the chain until the object handles it. Now, the sixth one is command, which encapsulates a request as an object, thereby letting us parameterize the client with a different requests, queues or log requests, and support undouble operations. The seventh one is composite. So here compose objects into three structures to represent the part whole hierarchies. Composite lets the clients treat the individual objects and composition of the objects uniformly. And coming to the next one, that is eighth one, which is a decorator. So here this decorator, it attaches the additional responsibilities to an object dynamically. So here the decorators, they provide a flexible alternative to the subclassing for extending the functionality. And the next one is facade, which provides an unified interface to the set of interfaces in a subsystem. So facade, which defines a high-level interface that makes the subsystem easier to use. Next, that is the 10th one, which is a factory method, which defines an interface for creating an object, but lets the subclasses decide which class to instantiate. So here factory method lets a class differ instantiation to the subclasses. 11th one is flyweight. So here this uses sharing to support large number of fine-grained objects efficiently. 12th one, interpreter. Here given a language, we define a representation for its grammar along with its interpreter so that uses the representation to interpret the sentence in the language. Next, iterator, which provides a way to access the elements of an aggregate objects sequentially without exposing its underlying representation. The next one is mediator. So here mediator, which defines an object that encapsulates how a set of objects interact. Mediators promote the loose coupling by keeping objects from referring to each other explicitly, and it lets us vary their interactions independently. The next one, that is 15th one, is memento. So here the memento, without violating encapsulation, it captures and externalize an object's internal state so that the object can be restored to its state in the latter stages. The next, that is 16th one, observer, which define the one-to-many dependency between the objects so that when one object changes the state, all its dependents are notified and updated automatically. Prototype, which specifies the kind of objects to create using a prototypical instance and creates a new object by copying this prototype. 18th one, proxy, which provides an surrogate or placeholder for another object to control access to it. Singleton, which ensures the class only has one instance and provides a global point of access to it. State. So this allows an object to alter its behavior when its internal state changes. So here the objects will appear to change its class. Next one is strategy. So here strategy, which defines a family of algorithms that encapsulates each one and make them interchangeable. So here the strategy lets the algorithm vary independently from the client that uses it. So here the strategy, which defines the skeleton of an algorithm in an operation and differing some steps to the subclasses. And the last one, that is 22nd one, is a visitor, which represents an operation to be performed on the elements of an object structure. So here the visitors lets us define a new operation without changing the classes of the elements on which it operates. Now coming to the second topic in this particular video, that is organizing catalogs. So here we classify the design patterns by two criteria. The first criteria called as purpose, which reflects what the pattern does. Here the patterns can have creational, structural or behavioral purpose. Creational patterns, they concern the purpose of the object creation. Structural patterns, they deal with the composition of the classes or objects. And the behavioral patterns, they characterize the way in which these classes or objects interact and distribute responsibility. Now coming to the second criterion, which is called as scope. Here the scope specifies whether the pattern applies primarily to the subclasses. So these relationships are established through inheritance. So they are static and fixed at the compile time. Here the object patterns, they deal with the object relationships which can be changed at the runtime and are more dynamic. Now, let us see the design pattern space in the table format. So, as we have seen that there are two criterion formats that are being classified. One is purpose and the other one is scope. And here the first criteria, purpose, here have creational, structural and behavioral purpose. And we have seen that the creational patterns, they concern the process of object creation, and the structural patterns, they deal with the composition of the classes or objects. And the behavioral patterns, they do nothing but they characterize the way in which these classes and objects interact, and they distribute the responsibility. Whereas coming to the second criterion, that is scope, here this scope specifies whether the patterns apply primarily to the classes or objects. So here class patterns, they deal with the relationship between the classes and their subclasses, and these relationships are established throughout the inheritance. So they are static and fixed at the compile time. Whereas the object patterns, they deal with the object relationships and which can change at the runtime. So they are dynamic. So classes are static and objects are dynamic. So this is the table form representation of the design pattern scope. Now let us go to the next topic, that is the third topic, how design patterns solve design problems. So design patterns solve many of the day-to-day problems where the object-oriented designers face, and in many different ways. So here we will discuss several of these problems and how the design patterns solve them. So to solve the first problem, we use finding appropriate objects. So here object-oriented programs are made up of objects and an object package, both data and the procedures that operate on the data. So the procedures are typically called as methods or operations, and an object performs an operation when it is going to receive a request from its client. So here in object-oriented design methodologies, they favor many different approaches. So we can write a problem statement, single out the nouns and verbs, and create the corresponding classes and operations, or we can focus on the collaboration and responsibilities in our system. Or we can model the real world and translate the objects that are found during the analysis into design. So there will be always a disagreement on which approach is the best. And the second design pattern is we need to determine the object granularity. So here objects can vary tremendously in size and number. Here the facade patterns, they describe how to represent the complete subsystems as objects. And the flyweight patterns, they describe how to support the huge number of objects at the finest granularities. So here other design patterns that what we have discussed previously, they describe the specific ways of decomposing an object into smaller objects. Abstract factory and builder, they yield objects whose only responsibilities are creating other objects, and visitor and command yield the object whose only responsibilities are to implement a request on another object or a group of objects. So here the other way to solve the problems, before going into that, let us see the mapping. So this is the mapping of determining the object granularity. Now let us go to the third uh, pattern to solve the problem, that is specifying object interfaces. So every operation declared by an object specifies the operation's name, the object it takes as parameters, and the operation that returns the value. So this is known as the operation's signature. Here the set of all signatures, they define the object's operation, which is called as interface to the object. An object's interface that characterizes the complete set of requests that can be sent to the object. So here, any request that matches a signature in the object's interface may be sent to the object. Here, the interfaces are the fundamental in object-oriented system, and these objects are known only through their interfaces. So here, there is no way to know anything about the object or to ask it to do anything without going through its interface. So an object's interface says nothing about its implementation, because the different objects are free to implement the requests differently. So that means that when two objects having completely different implementations, they can have identical interfaces. Now the fourth method to solve the problem is by specifying the object's implementations. An object's implementation is defined by its class. Here the classes are which specifies the object's internal data and representation and defines the operations the objects can perform. So here our OMT based notation, which depicts a class as a rectangle and with the class name in the bold. So here operations appear in the normal type below the class name, and any data that the class defines comes after its operation. And here lines we are going to use to separate the class name from the operations and the operations from the data. And the return type and instance variables types are optional, since we don't assume a statically typed implementation language. So here objects are created by instantiating a class. So the object is said to be an instance of the class. So here the process of instantiating a class allocates the storage for the object's internal data and associates the operations with these data. So here many similar instances of an object can be created by instantiating a class. So here a dashed arrowhead line which indicates a class that instantiates the object of another class, and the arrow point to the class of the instantiated object. So here a new class can be defined in terms of the existing classes using class inheritance. So when a subclass inherits from a parent class, it includes the definitions of all the data and the operations that the parent class define. So here the objects that are instances of the subclass will operate or will contain all the data that is being defined by the subclasses and its parent class. And they will be able to perform all the operations that are being defined by the subclass and its parents. So we indicate the subclass relationship with a vertical line and a triangle. An abstract class is one whose main purpose is to define the common interfaces for its subclass. An abstract class will differ some or all of its implementations to operations that are being defined in the subclass. Hence, an abstract class cannot be instantiated. So here the operations that an abstract class declares but does not implement are called as abstract operations. So the operations that an abstract class declares but does not implement are called abstract operations. And here the classes are not abstract, are called as concrete classes. Here the subclasses can refine and redefine the behavior of their parent classes. So more specifically, a class may override an operation that is being defined by its parent class. Now, let us go to the next topic, that is how to select a design pattern. With more than 20 design patterns, what we have discussed in the starting of this video, in the catalog to choose the form, it might be hard to find the one that addresses a particular design problem, especially if the catalog is very new and which is unfamiliar to you. So here there are several different approaches to find the design patterns that is right for your problem. So when you have identified your problem, we need to see which catalog pattern we need to use for that particular problem. So for that, the first approach what we are going to use is consider how design patterns solve the design problems. So here the design patterns, they help you find the appropriate objects and determine the object granularity and specify the object interfaces and several other ways in which the design patterns solve the design problem. So referring to these discussions may help or guide you in search for the right pattern. And the second approach what we use is scan intent sessions. So here lists the intent sessions from all the patterns in the catalog. Read through each pattern's intent to find one or more that sound which is relevant to our problem. Then the third approach is study how the patterns interrelate. So here the relationship between the design patterns which are represented graphically, and by studying these relationships can help directly or which will direct us to the right pattern or group of patterns. The fourth approach is study patterns of like purpose. So here the catalog has 3 chapters, one for creational patterns and another for the structural patterns and the third for the behavioral patterns, which we have already discussed. So each chapter starts off with an introductory comments on the pattern and conclusions with a section that compares the and contrasts them. So these sessions, they give you the insight into the similarities and the difference between the patterns of the like purpose. And the fifth approach what we use is we need to examine a cause of redesign. So we need to look at the cause for the redesign, then look at the patterns that help us in avoiding the causes of redesign. And the sixth one is considering what should be available in your design. So this approach is quite opposite of the focusing on the cause of redesign. That is our fifth approach. So here, instead of considering what might force a change to a design, we need to consider what we want to be able to change without redesign. So fifth and sixth, they contradict with each other. So these are the 6 different approaches what we are going to use for how to select a design pattern. Now, once after selecting the design pattern, we need to see how we can use them. So let us move to the next topic, that is how to use a design pattern. So once when we pick a design pattern, that is how do we use it? So how can we use it? So for that, we need to follow a step-by-step approach to apply a design pattern effectively. So we need to go step by step. So here in the first step, we need to read the patterns once through for an overview. So here we need to pay particular attention to the applicability and consequence sections to ensure that the pattern is right for our problem. Then in the second step, we go back and study the structure, participants, and collaboration sessions. So here, this makes sure that we understand the classes and objects in the pattern and how they need to be related to one another. And in the third step, we need to look at the sample code session to see a concrete example of the pattern in the code. So here, by studying the code, that helps us learn how to implement the pattern. And in the fourth step, we need to choose the name for a pattern that participate and that are meaningful in an application context. So here, the names for the participants in the design patterns are usually too abstract to appear directly in an application. Of course, nevertheless, it's useful to incorporate the participant's name into the name that appears in the application. That helps make the patterns more explicit in the implementation. For example, if we use the strategy pattern for a text composing algorithm, then we might have the class with simple layout strategy, or we may have with a text layout strategy. And in the fifth step, we need to define the classes. So here, once after declaring their interfaces, we need to establish their inheritance relationships and define the instance variables that represent the data and object references. So here, identifying the existing classes in our application that the pattern will affect and modify them accordingly. And in the sixth step, we need to define application specific names for operations in the pattern. Here, once again, the names generally they depend on the application. So we need to use the responsibilities and collaborations associated with each operation as a guide. And also, we need to be consistent in our naming conventions. For example, we might use the create prefix consistency to denote a factory method. And in the seventh and the last step, we need to implement the operations to carry out the responsibilities and collaborations in the pattern. So here, the implementation session offers the hints to guide us in the implementation. For example, the sample code section can help us well. So this is how we need to use the design patterns by using these 7 step-by-step approaches, or 7 by applying the 7 step-by-step approaches. Because by using these 7 step-by-step approaches, we can design the patterns more efficiently. Thank you. If any questions, you can find me at arvind.ynd@newton.edu.in. And for any admissions, you can contact me at 9494470795. That's all for now. Thank you all. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you one and all.